Alright, this video is going to talk to you about exponents and the product rule. The first part of this video, we're going to review some skills that you talked about in 7th grade and in 6th grade math, and then we're going to take it to the next step and we're going to learn what you need to learn for 8th grade. Okay? So reviewing what we talked about in 6th grade, you learned that, let's say you had 2 to the 4th power. Okay? That means that you really have 2 times 2 times 2 times 2, okay? You learn about this form being known as exponential form. Okay? It means you've got multiplication that is written in a condensed format. Well, we call this form expanded form. Okay, and that makes sense because you take your exponent and you write it out as though you're showing the product of those numbers however many times you need to. Okay? So again, talking about a little bit more review, let's say we have 2 to the 4th, some vocabulary that you need to be familiar with. This number is called the base. Okay, the number that you're raising to the power is the base, and then the number that is the power is the exponent, okay? The exponent tells you how many times are you multiplying a number times itself, okay? Like I said, and like we saw up here, 2 to the 4th power is the same thing as 2 times 2 times 2 times 2. It's important for us to know that because we're going to be talking about different properties that we can apply to terms that are written in exponential form. And in order to understand why those properties work, you've got to know the difference between exponential form and the expanded form. Okay? So moving on, let's look at an example just to kind of discover what I'm talking about, the product rule. So let's go back to that 2 to the 4th power. I like that. And let's say I want to multiply this number by 2 to the 3rd power. Okay? First of all, I just want to clarify, I'm going to go back, and I should have done this earlier, but I want to go back and I want to remind you that 2 to the 4th power is not equal to 12. I'm sorry, well, I don't even know how you get that in the first place. Is not equal to 8. You do not multiply your base times your exponent. If you ever do that, I will throw up on you. It is disgusting. Don't ever do that. You need to remember that exponential form is the condensed form of showing a repeated multiplication. Okay. So now that we can get past that, I want to come back to this problem. Okay, so looking at 2 to the 4th power as we just reviewed, we have 2 to the 4th power being 2 times 2 times 2 times 2. If I'm going to multiply 2 to the 4th power by 2 to the 3rd power, then I'm going to say 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, so I took two different terms that were written in exponential form and I expanded them out to show the product of all those numbers being multiplied together. If I wanted to condense this back down into exponential form, take everything that I just expanded and recondense it, I would get 2 to the 7th power. Again, how did I get that? Well, I just simply counted. I have 1, 2, I have 2 2s, I have not another 2 2, I have 3, I have 4 2s, I've got 5 2s, I've got 6 2s, I've got 7 2s. So again, taking that expanded form and recondensing it back down into one singular exponential form, I'm able to determine what 2 to the 4th times 2 to the 3rd is in a condensed format, in a simplified form. Okay? Looking at one more example before we kind of talk about what the power rule is, because you probably just noticed something, and hopefully you noticed something. Let's say I have x to the 3rd times x to the 4th times x. Okay? Again, taking each of these and expanding them out and showing the product will help us understand why this works. So x to the 3rd is the same thing as x times x times x. X to the fourth is the same thing as saying x times x times x times x. And then multiplying it by another x, that third, just singular x terms, words is hard, okay? If I was to ask you, what is the exponent for this term, okay, there is not one, so it's always understood to be 1. Okay, so anytime that you have a term that does not have an exponent, you should understand it to be 1. Always understand it to be 1. Okay? So again, taking this form, and I want to recondense it back down into one singular exponential form. If I count my x's, I have 1, 2, 3, 4, 5, 6, 7, 8. So x to the third times x to the fourth times x is the same thing as x to the 8th power. Again, you probably noticed something. And hopefully you do. If you don't, then, oh boy. Anyways, so coming back and let's look at the product rule. Okay, the product rule says, if you have two terms with the same base, okay, important here, same base. Two terms here with the same base. If you multiply those terms together, you can add their exponents. You keep the base the same, but simply add their exponents. That's the product rule. You multiply, you add, okay? When you multiply, you add. When you have the product, you add those exponents, okay? You're going to hear that again later whenever I rap to you. Yes, I do have a rap, and yes, it is sick. Expect my mixtape to drop pretty soon. It's pretty legit, so be excited about that. But anyways, coming back to this, I'm going to go back to that example that we first started talking about in the last page, and I'm just going to give me a second so I can copy it. Copy, yep. You don't see anything happening. It's a good thing. And let me paste it right here. There we go. Yeah, just magic. I'm magical, if you can't tell. Okay. What the product rule says is you've got two terms that have the same base. Okay. So instead of having to write it out in expanded form and then recondense it back down, I can use the product rule to say 2 to the 4 plus 3, which gives me 2 to the 7th. Again, why do you add? Well, if we're coming back here and looking at this expanded form, when I wrote everything out, I got each of the terms spread out. I was able to look at every single iteration or every single digit of this multiplication problem. And since it's all multiplication, technically, when you have an exponent, you have repeated multiplication. You've got multiplication here. Okay, so basically what you're doing is repetitive multiplication, which sounds like adding, right? When I say, I know that probably doesn't make any sense, but what I'm trying to say is, right here in this situation, I've got repetitive multiplication. And if you think about it, if you're repetitively adding something, that's how you get multiplication. That's what multiplication is. 2 plus 2 plus 2 plus 2 plus 2 is the same thing as 2 times 5. Okay, well, this is repetitive multiplication, so we're ultimately adding those terms, those repeating terms, and combining those terms into one. So that's why we add, okay? Again, looking at that second example, and I'm just going to say x to the third times x to the fourth times x. Again, it's important with the product rule that anytime that you have an exponent that's not included here, like for this example, the x doesn't have an exponent written, so it's understood to be 1. You're going to want to include 1. Your biggest mistake is going to be forgetting the fact that x term is a factor itself. It's its own term. Okay? So, this is the same thing as saying x to the 3 plus 4 plus 1, which gives me x to the 8. Very, very simple. The product rule is very, very simple. There's really not a whole lot to it. So what I want to do is I want to go through some examples here, and I want to talk to you about some more examples before I let you practice, before you have time to practice some of this on your own. Okay, so looking at another example, let's say I have 2 to the 4th times, I like that, don't I? I need to back away from that. Let's say 6 to the 1st. No, let's not say that. Oh gosh, I'm embarrassing myself. I'm embarrassed. All right, 6 squared times 6 times 6 to the 8th times 6 squared. I don't know, just something crazy. Again, I'm going to show you the long way, and then I'm going to show you the product rule and why we're allowed to use the product rule. So I have 6 squared, so 6 times 6. And then I've got times 6. And then I've got 6 to the 8th, so 6 times 6 times 6 times 6 times 6. Oh boy. 1, 2, 3, 4, 5, 6, 7, and 8. Times 6 times 6. Okay, again, there are all of the factors of 6 written out in expanded form. And then if I want to condense this back down into exponential form, I just need to take however many 6's there are and raise it to the power of those factors. So again, if I'm counting these, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 factors of 6, so my exponent is 13. Okay, now that took a little while, but if I was to use the product rule, okay, if I was to use the product rule, copy and paste, talking to myself like you know what I'm talking about, good deal, you know, typical crazy math teacher. Okay, you know, and I'm OCD, so I want to erase these really quick. Okay, so then looking at the product rule says, okay, you have repeated multiplication of a digit that is raised to a power. So you take that base, which in this case is 6, and you say, all right, well, let's just add their exponents together. I've got 6 squared times 6 to the 1st, which is, make sure you include that 1 as your exponent, times 6 to the 8 times 6 squared. So it's 6 to the 2 plus 1 plus 8 plus 2, which gives me 6 to the, adding that up, I get 13. So it's much faster to do it this way than it is to write it out in expanded form and recondense it. The product rule allows you to save some time. All right, moving on. Let's look at another example. Let's make it a little bit more complicated. Let's say I've got, okay, let's go with 4. Let's say 4 to the 3rd times x squared times 4 to the 5th times x to the 7th. Okay, now this is important because I have two different terms that have exponents. I have 4's with exponents, and I have x's with exponents, okay? I always want to remember the definition of the product rule. You can add the exponents when you have the same base to powers. Okay, so what do I mean by that? I mean I've got 4's, but I also have x's. Okay, I can only combine like terms. So I really have 4. I can rearrange this problem to put my like terms together. So I have 4 to the 3rd times 4 to the 5th. I can do that because of the commutative property of multiplication. Because it's all multiplication, I can do this. Times, putting my x's together, I have x squared times x to the 7th. The product rule says, okay, I've got 4's raised to power, so I can add those exponents together. I've got x's raised to a power, so I can put those x's together. So what we started with is the same thing as saying 4 to the 8th times x to the 9th. Your final answer, you just need to drop that multiplication symbol between. A very simple problem. Okay. Let's do another example here. Let's say we've got something a little bit more complicated, and then we'll call it a day, and I'll let you practice this. I've got 3 squared times x to the 4th times y to the 3rd times 3 to the, just say 3 times y to the 8th times 3 squared times x times y to the 4th. Okay, I know this looks really crazy. It is, but we're going to make it very easy. Again, I can only combine like terms, so what I want to do is I want to find my like terms, and I want to rewrite this expression so that way I'm putting them together. So 3 squared, I'm going to put my 3's together. So 3 squared times 3 squared. Okay, then I want to take my x's and I want to put my x's together. So x times x to the 4th times x. Then I want to take my y's and I want to put my y's together. So times y to the 3rd. Whoa, that's the ugliest 3 I've ever seen in my life. Times y to the 8th. Times y to the 4th. Again, all I did was I just rearranged, using the commutative property of multiplication, I rearranged this expression to put my like terms together. And now I can apply the product rule. First, I want to double check and make sure that every term has an exponent, okay? Looking at this 3, it doesn't have an exponent written, so it's understood to be 1, so I'm going to include a 1. I'm going to write a 1 up there. Same thing with that x. That x is missing an exponent, so I'm going to put it together. Okay? So then moving on, I'm going to say, all right, well, I've got 3 to the 2 plus 1 plus 2 times x to the 4 plus 1 plus 3 times y to the 3 plus 8 plus 4. Again, I can do that because it's repetitive. Oops, I think I messed up. Hold on. I messed up. Coming back over here, though, I need to take away that plus 3 because there's not an x to the 3rd. My bad. My B-dogs. I got excited there with that y to the 3rd, and I wanted to include it. It wanted to be an x so bad. Anyways, okay, my lame jokes are through. So I have 3 to the 5th, 2 plus 1 plus 2 is 5, times x to the 5th, times y to the 12th, so 15. Again, I just want to rewrite my answer by dropping those multiplication product symbols. So 3 to the 5th, x to the 5th, y to the 15th. And that's it. That's really all there is to the product rule. The product rule is very, very simple. As long as you understand why the product rule it applies, then I'm happy. I want you to understand that the product rule is not a shortcut. Even though it kind of makes the work shorter, the product rule is created because of that repetitive multiplication. The repetitive multiplication, as we saw on this screen here, especially this portion right here, this repetitive multiplication allows for us to apply the product rule. Okay? You can only do this when you have, like in this example, in the last example we just did, you can only combine like terms. So only combine your 4's, in this case, and only combine your x's. You cannot combine unlike terms. You can't mix oil with water, so don't even try. Same thing here. I only combine my 3's together, only combine my x's, only combine my y's. Okay. All right, and then I always draw a little smiley face just so I can show you what I bet some of your faces are looking like right now, kind of like, but anyways, I hope you understand this, and product rule, yeah, woo.